During this hands-on session, we are going to learn how to install the SimStack client for Linux and Windows OS, and how to set up the server to allow your machine connect with your HPC resource. And we will learn how to build those three workflows here. The first one is a simple workflow composed of 2 Wanos, and the second one is slightly complex because we have 4 Wanos here, plus the for each loop control. At the end, we should be able, for example, to branch a workflow using the if feature, which is already embedded in SimStack. Then let's jump in. Here we will start by installing the SimStack client in Windows. And the first thing that we have to do is download the latest client version from the SimStack website. Okay, let's open our browser here. And here we have the latest version for Windows. Let's download it. It's almost there. All right, it has finished. Let's check our download folder. Okay, it's here. Let's just move to the desktop area just to make our life a bit easier. And let's unpack this. All right, we already start to extract the files. Great, it has finished. And now let's run SimStack. Okay, all right, this is something that might happen to you as well. Windows might prevent you to install SimStack. You have to come here, more info, and run anyway. Okay, during this first launch, the client version will install all needed dependencies. Okay, don't worry, now we have just to wait. Okay, all right, it has finished the installation. Now what we have to do is just make the setup for the configuration, but as the setup is the same for Linux and Windows, we are going to do this for Linux, okay? Install SimStack in Windows is simple, like you just saw here. Okay, all right. Here we are going to start by installing the SimStack for the Linux OS, and then the first thing that we have to do is go to the SimStack website and download the latest version of SimStack for Linux OS. I already came in here a couple of times, and this should be your choice here, for example, okay? You have to click on it. This is we'll start the download, and let's save it. All right, it's downloading the file. All right, the download has finished. Now let's check our download folder. Let's just move this for this desktop area just to keep things more easy to access here. All right, and let's extract the information. All right, the information has been extracted, and now what we have to do is just move inside of this folder here, and we have to open our terminal now, and we have just to run this command here. Now we have just to press enter and wait a bit. All right, you have to press Q here and accept the conditions here, and now all the dependencies is going to be installed, and we have just to wait a bit. All right, the installation has finished, and we have the SimStack client GUI here. It's pop up to us, right? Now what we have to do is set up the server to allow our machine connect with our HPC resource. For this particular case here, I'm going to use this INT Bionano machine as our HPC resource. So let's make the configuration here, the server, and we have to create a new tab here. And now we have to fill up those fields. If you run this tutorial in Bionano, for example, you can come in here in SimStack documentation and go to the installation. And yes, and here you have, and we have just to copy those information and paste in our SimStack server here. All right. Okay, let's do that. Okay, here I'm going to put INT Bionano just to name my machine. All right. My base here should be this one here. It's the same that we have here, port 22. I already have an account here. My username is tutorial01. This is my SSH key, and you have to load it. All right. And the base path we are going to keep here to leave like it is here. And the extra config file we don't have. And let's switch for Slurm. And the software directory on cluster, we should change to shared. Oh, sorry. We should change it to this one here. All right. And here let's switch from the default to the batch queue. All right. And let's save it. Now we made the setup for the server, and let's try to connect. Now your local machine is connected with your HPC resource. Okay. All right. And let's come back in the configuration and set the path. Let's choose a folder. I've created, for example, 2 folders in the desktop area, one for workflow and another one for the Wanos. This one here for the workflow, for example, you have to come here in desktop. And here's the folder where we are going to save our workflow that we are going to build, okay? Let's choose this, and for this particular case here, I've created this Wanos folder, and you have to select it and choose and save it. Okay, now we are good to import the Wanos, and for that we have to go to the PMD store. All right, and download some Wanos from there. Okay, so let's take a look in the SimStack documentation and this tutorial part here. Let's decrease a bit. All right, and here we use, for example, 5 different Wanos. We are going to use the projectile motion Wanos, right? And we use the range each, the table generator, and the plot figures, and the stop Wano. All right. Now we have to go to the PMD store and make the download of those Wanos. Okay. The first thing that you have to do is log in. All right. Actually, I already downloaded the most of the Wanos that we are going to use during the hands-on. Is missing just one. That is this one here. If you are using the Linux OS, for example, I suggest you to download the tar format. If you are using the Windows, I suggest you to use the zip format. Okay, all right. As we are doing this for Linux, let's download this one here, and you have just to click OK, and then we are good there. And now let's check in the download folder. Okay, we have all the Wanos are here. We have 5 of them. When we unpack those Wanos here and save in the Wanos folder, for example, let's click on it. We don't have enough here. After refresh the SimStack client, we should be able to see those Wanos in the nodes area. Okay. All right. Let's extract them. Let's open with files, and let's open with other application. Archive manage, and let's click on it. Let's extract, and this is going to ask where we want to save it, and of course we want to save it in the Wanos area, right? Let's extract. Okay, it has finished. Yeah, we have just to repeat this for the other files. All right, we already extracted all the Wanos. Let's close it, and now we have saved those 5 Wanos here in the Wanos folder. Now we can refresh. We have to go in the configuration, paths, and let's save it. Wow, look here, we have 4 Wanos here, but one is missing. Why it's missing? Okay, I have to be honest here. This was intentionally, right? The main reason why we have only 4 Wanos here instead of 5 is because the name of the projectile motion doesn't match with the XML file here. Instead of use, for example, here we have lowercase for both, and here the name of the folder is with uppercase. We have just to change the name, and let's put, for example, uppercase to lowercase, and then we have to refresh again, and this is going to show us the new Wano. Okay, all right. Now we have all 5 Wanos here, and we are good to start to build the workflows. Let's check in the SimStack documentation what we have to do. The first task is build this workflow here. It's a combination between projectile motion and plot figures. In this case, we are going to compare 2 different systems, smoothball and smoothball plus drag effect. So far, so good. Let's move to the SimStack. Okay, let's move these plot figures to the main canvas area and the projectile motion. Okay, let's make the setup for the projectile motion. Remember that we want to compare 2 different systems. Then we should have 2 different set of parameters, right? And in this case, let's put the label here. Just we can choose any name, but let's use the same that we have in the tutorial documentation. Set 1, and here is set 2, and here we should change it to smoothball plus drag effects. Okay, so far so good. All right, and here we have the resource. As it is a very simple simulation, you don't really need too much computational resource for that. In this case, we are going just to use one CPU, only one node, right? With this memory here, with for this time wall in this queue. And now let's set up the plot figures. As we want to compare different systems, we should plot on the same graph, right? And this is the name. We are going to leave like it is here. And the title, we can just put drag effect. The X and Y coordinate, we can use X and Y in meters, because this is the unit of the simulation. And in this file here, the information for the X and Y coordinate, they are labeled, for example, like this. For the first set of parameter, we have X0 and Y0. For the second set, X1 and Y1. And if we would have, for example, a third one, you would have X2, Y2, and so on, all right? So in this case, let's put set 1 here. In this case, let's put just a smooth here, and let's create a new set. And here should be X1, Y1, and here let's put just a drag, okay? So far, so good. What we have to do now is come here in File and save our workflow. Okay, in this case, let's just put Proj 1, for example, and let's save it, and now we run it. First, we have to connect our client to our server, all right? It's connected. We have to come here and press Run. And now you can come in here in the workflows, for example, click on it. You are going to see a yellow folder. Yellow means that your calculation, your simulation is running or is waiting, all right? Now it's green. Green means that your calculation has finished successfully without any computational issue. And let's see the figure. Let's click on it. You can browse this folder here by click with the right button of your mouse. You can click on it. This is going to pop up to you those options here. And you can browse the directory here. And this is going to pop up to you the files that are in the folder, okay? And let's click on it, and boom, you just finish your first workflow in SimStack. And yeah, let's see our next task. Okay, now we are going to combine those 4 values here plus the for each loop control, all right? At the end, you should get this figure here where we are going to plot, for example, the maximum range against the maximum highest of the ball, okay, during the movement of the ball, and the maximum range against the time to the target. Let's switch back to the SimStack. Okay, the first thing that we have to do is drag and drop the Wanos to the main canvas area, right? And for this particular case, we are going to use the for each loop control. Let's move it down. And inside of the for each loop control, we should drop this projectile motion. And below the table generator, and below the table generator, the plot figures. Now let's make the setup for the range it, and we can switch back to the documentation, for example. What we are going to change here? Actually, the variable that we will iterate over it is this initial velocity here, right? So in this case, we are going to create a list of values here within this range it, and pass this information to the for each loop control, which in turn will pass to the projectile motion. And we will extract this information with the table generator and the plot with the plot figures. Okay, all right. And here we have 2 options, float and int. As the initial velocity is a float variable, we should choose this one here. And we are going to range this from 20 meters per second until to 70 meters per second. And we choose here 20 points, right? Here we should import the range it, and you can start, for example, by typing range it. This is going to pop up to you some options, and this is going to show you 2 options here. This range it dot iter dot 0, for example, or dot 1, and you can stick with the first one. But instead of use 0, you are going to remove 0 and replace it by a star. All right, okay, and you have to save, click just OK here. And now we are going to pass this information to the initial velocity here. We have to click here in this button here, and this is going to ask you to import the variable. And now we are going to start by type 4 of for each, and your choice should be this one here, okay? And now we will pass the information from the for each loop control to the table generator. This table generator Wanos will create a file, a YAM file, where we are going to save the data to plot with the plot figures, right? Okay, the file that we are going to use here is the proj out file, right? Proj out.yam file. Great, and let's import it. You have, let's minimize this window here just to make clear what we are going to import. Okay, and now we have to select the file that we are going to import. And this one should be your option here. We have just to click once, and then we are good. And let's maximize this again. And okay, yes, and you already did this. And now we will create, for example, the variable that we are going to search. Here we have to create 3 variables that we are going to search in this proj out. They are, for example, in this case, they are the X max, that is the maximum range or the range of the golf ball, the range of the ball, and Y max, that is the highest point of the ball. And in this particular case here, time to target. And you should write like we are doing here. Now let's make the setup for the plot figures. Okay, and now we import the file to make the plot. All right. And as I said, we generate the table generator is create this table var dict yum file. Okay, and you should choose this one here. Okay. But now we are not going to use the same graph because we want to make subplots, right? You should click here, choose, okay, let's leave the name of the figure like it is here, and the title should, but for this particular case, let's just use, for example, proj motion, for example. And here we will create two sets of variables, right? But now we should change, for example, this is the X axis and this should be X max and here Y max. All right, so far so good. And here's the label, we can keep it the same name. And here is X max again and time to target. Okay, here let's keep the same and here too. And now what we have to do is save the workflow. And for example, let's save it as proj2, for example. All right, now let's connect our client with our HPC. Great. And let's run it. Click here. And now it's running. We can come here in the workflows and check. Okay, now we've created project 2 and you can reload it. Let's click on it. All right, we already finished this first part. Remember that the information is flowing from the top to the bottom here, right? Then we create several folders, name it projectile motion. Actually, the name of those folders are different, but here it's appear to you as being the same, but they are different, right? And yes, this part here is created inside of the for each loop control. And now let's see if it has finished. It has created, for example, the table generator and the plot figure. Let's see the plot figure and let's click in this plot, subplot PNG, for example, and boom, yes. Congratulations, you did your second workflow using SimStack. The main reason to build this workflow is to prevent the unphysical result. Why that? Well, if we choose, for example, golf ball plus drag or golf ball plus lift effect, the initial velocity that we can use here is only valid for values between 13.7 and the 88.1 meters per second. So in this case, we have to be sure that the simulation that you are running has a physical meaning, right? And that's why we have to impose this constraint here. Okay, all right, let's do this in SimStack. Okay, now let's build the workflow itself. Okay, in this case, we are going to use this variable feature here with the if condition, and inside of the left run side, we are going to put the plot figure combined with the projectile motion, right? And in this side here, we are going to put the stop message. Essentially speaking, we are going to put a condition here. If this condition is satisfied, this workflow will run this part here. Otherwise, this is going to run this side here, right? So let's give a name for our variable here. In this case, let's call just val v0, for example. And let's start with a value that is within the interval that we just mentioned here. Let's choose, for example, 85.0. It's a good choice here. We still are going to be within the valid interval here. And let's put the condition here. The condition should be val v0 should be larger than 13.7, right? And the val v0 should be lower than 88.1 meter per second. Let's choose the system here to be golf ball plus drag. So we've done in this part here of the projectile motion. And now the plot figures, let's import the data here. The file that you should import is this proj data. Let's just click once here, that's fine. And we are going to plot on the same graph, right? And here the X and Y coordinates should give in meters. Let's just put the appropriate units here. And here, let's just put, for example, set 1, right? Like we did here for the projectile motion. And here you can write your stop message. Let's just remove and just leave the stop message like it is here, right? And what we have to do is save it. Let's save our workflow. And let's use, for example, proj3, right? Okay. And now we are good to run. Let's first connect our client to our HPC. Now it's green, okay, it's running. Let's reload it. Okay, it's yellow, means that it's running or waiting. And we already finished the first part here, the project time motion. Remember that the value that we choose here is within this interval, then this is going to run this side of the workflow. If we choose, for example, a value that is outside of this interval here, this is going to run this stop message here, right? Let's check if it's made the plot for the X and the Y coordinates, and yes, and it has done. Let's choose a value that is outside. For example, instead of being this value, let's choose, for example, 12. That is outside of the value. What we have to do is come here, save again, and run it. And let's check which part of the workflow this is going to run. It has finished. It was very quickly because in this case, we have just to evaluate this condition here, and then we have this stop message here. And let's check the stop message file. That is this file here. And just what we've written here is the same that is here now. Great. With that, you successfully finish all the 3 workflows proposed in the SimStack documentation. Congratulations, you just finished your first SimStack tutorial. If you want to learn more about SimStack and how to use it to manage your simulation protocols, send us an email and we'll be glad to help you. All the links are in the description below. I hope you enjoyed the video. If you did, share it with others, and thanks for watching.